2.1 Frequency Distributions for Quantitative Data. A frequency distribution is a collection of observations produced by sorting observations into classes and showing their frequency, which is f, of occurrence in each class. In Table 2.1, the observations are sorted into classes of single values, which the result is referred as a frequency distribution for ungrouped data. A frequency distribution for ungrouped data are much more informative when the number of possible values is less than 20. In Table 2.2, the observations are sorted into classes of more than one value. The result is referred to as a frequency distribution for grouped data. Data are grouped into class intervals with 10 possible values each. Distance from bottom to top is occupied by an orderly series of classes. The frequency column shows the frequency of observations in each class. You and then add them up to get the total. In section 2.2, it talks about the guidelines. So the guidelines for frequency distributions, the essentials, and you need to know. 1. Each observation should be included in one and only one class. For example, 130 to 139, 140 to 149, 150 to 159, and so on. It would be incorrect to use 130 to 140 because the boundaries of classes overlap and observations of 140 or 150 could be assigned to either of two classes. 2. List all classes, even those with zero frequencies. Example, listed in Table 2.2 is a class 210 to 219, and its frequency of 0. It would be incorrect to skip this class because of its zero frequency. 3. All classes should have equal intervals. Example, 130 to 139, 140 to 149, and 150 to 159. It would be incorrect to use 130 to 139 and 140 to 159, in which the second class interval, 140 to 159, is twice as wide as the first class interval of 130 to 139. These ones are optional. All classes should have both an upper boundary and a lower boundary. 240 to 249. Less preferred would be 240 and above, in which no maximum value can be assigned to observations in class. 5. Select the class interval from convenient numbers such as 1, 2, 3, so on, particularly 5 and 10 or multiples of 5 and 10. Examples, 130 to 139, 140 to 149, in which the class interval of 10 is a convenient number. Less preferred would be 130 to 142, 143 to 155, and so on, in which the class interval of 13 is not a convenient number. 6. The lower boundary of each class interval should be a multiple of class interval. Example, 130 to 139 and 140 to 149, in which the lower boundaries of 130 and 140 are multiples of 10. The class interval less preferred would be 135 to 144 and 145 to 154, and so on. 7. Aim for a total of approximately 10 classes. A unit of measurement is the smallest possible difference between scores. And there's real limits located at the midpoint of gap between adjacent table boundaries. Constructing frequency distributions. Find the range. That is the difference between the largest and smallest observations. Find the class interval required to span the range by dividing the range by the desired number of classes. Round off the nearest convenient interval. Determine where the lowest class should begin. In the present example, the smallest score is 133, and therefore the lowest class should begin at 130, since 130 is a multiple of 10. Determine where the lowest class should end by adding class interval to the lower boundary and then subtracting 1 unit of measurement. In the present example, add 10 to 130 and then subtract 1, the unit of measurement, to obtain 139, the number at which the lowest class should end. Working upward, this lists as many equivalent classes as are required to include the largest observation. In the present example, list 130 to 139, 140 to 149, and so on, so that the last class includes 245, the largest score. Indicate with a tally the class in which each observation falls. For example, the first score in table 1.1, 160, produces a tally next to 160 to 169. The next score, 193, produces a tally next to 190 to 199, and so on. Replace the tally count for each class with a number, the frequency, and show the total of all frequencies. Lastly, 9. Supply headings for both columns and a title for the table. That should be an automatic must-do. Then you have outliers in 2.3. An outlier is a very extreme score. An outlier is a number that stands out from the rest. It's going to be noticeably larger or noticeably smaller than the other numbers. So that's what an outlier is.